Topic is limitations of Docker with respect to Kubernetes. We will discuss what are the limitations of Docker and how it is not an enterprise level platform. Although Docker is an exceptional tool for packaging and running applications in isolated environments called containers, however, Docker, specifically standard Docker engine, operates primarily at the single host level. It handles the creation and execution of containers beautifully, but it lacks the built-in intelligence to manage those containers dynamically at scale. So it says like for packaging and running applications, Docker is an exceptional tool. However, Docker operates on a single host level, which means on a single virtual machine or on a single instance, for example. So it has issues with storage if it only works on single host level, and also it handles creation and execution of containers beautifully, but it doesn't have the built-in intelligence to manage that containers dynamically at scale, which means it cannot scale up or scale down or manage those containers, which Kubernetes does. So here are some points to note. First is Docker is ephemeral in nature, that is volatile life cycles. The Docker reality: containers are designed to be stateless and temporary. If a container crashes or the underlying host fails, the container and its internal data are gone, which means containers are stateless and temporary. If a container crashes or its host fails, container and its data is gone. The problem: in production environment, manual intervention is required to recreate the container, patch storage, and restore service. So even if we use Docker, for example, in a single virtual machine or a single host, we would have to manually intervene to recreate the container, to attach the storage, and to restore the service if the container fails, which is inconvenience in itself, which Kubernetes solves. Second is single host nature, that is resource contention. The Docker reality: Docker typically runs on a single physical or virtual machine. As I said, Docker runs on a single virtual machine or a single physical server, that is, for example, Ubuntu or T2 Micro in an AWS. So that is a single virtual machine that you allow Docker to run your applications. The problem: there is no native intelligent cluster-wide scheduler. If one container consumes 90% of the host's CPU or RAM, other containers on that same host will starve. Docker cannot automatically look at the group of different servers and say, this server is too busy, let me launch the next container on that idle server over there. So to explain the problem, Docker is a single host platform or single host nature. It doesn't have intelligent cluster-wide scheduler, that is, it doesn't operate on multiple virtual machines or multiple servers. That means it doesn't operate on multiple instances. That means if it works on a single virtual machine, it would only have resources that are allowed in the single virtual machine. So the problem comes is if one container consumes 90% of that virtual machine or that host or that instance, 90% of the CPU or RAM, so other containers that are on that instance that needs resources too will not get that resources. So that other containers will stop or that containers would not run. Only that 90% or that single container would run because it doesn't have that much storage or capacity to manage as it operates on single virtual machine or single host. The most important point to note is that Docker cannot automatically look at the metrics. It doesn't have that intelligence to look at or understand your application or the containers to say that this container is occupying a lot of space and other containers are not getting resources. So let's just create another instance, or let's just switch into that another instance or another virtual machine so all containers are up and running. Instead, it would only run a single container and the other containers would not run. Now third is lack of auto healing. The Docker reality: if a containerized application freezes, deadlocks, or crashes, the standard Docker engine does not natively monitor application level health to actively replace it. So Docker does not monitor application's health actively to replace or to create a new container. If a container freezes, deadlocks, or crashes, downtime occurs until human or external script notices the failure and manually restarts the container. Fourth is no native auto-scaling and load balancing. Docker does not natively monitor incoming network traffic to spin up additional copies of container. So it is same. Docker does not monitor traffic and everything. So it cannot spike up or spin more containers if the traffic or the network traffic, incoming traffic increases, and it cannot scale down if the traffic is normal or it is not that much. The problem if the traffic spikes from 1000 to 1 lakh requests per second, Docker cannot automatically provision new containers and distribute the traffic evenly among them. So that was about the limitations and drawbacks of Docker. Now let's see how Kubernetes, the orchestrator, solves those problems and that limitations of Docker. To solve these exact enterprise limitations, we need container orchestrator. This is where Kubernetes KTS comes in. Kubernetes does not replace Docker. Instead, it uses Docker or other container runtimes to run containers while Kubernetes handles the management. Simply, Kubernetes does not replace Docker. It uses the features of Docker that Docker operates or containerization or it platform to run containers while Kubernetes as a service handles the management of those containers. That means the creation, the scaling, the monitoring of containers, which was the limitation in the Docker, and it is managed by Kubernetes. First is solution to ephemeral nature. Kubernetes uses pods, the smallest deployment units, and controllers like deployments. If a pod dies, Kubernetes automatically spins up an identical replacement instantly. It also manages persistent storage volumes that remain intact even when the container dies. So simply in Kubernetes, the smallest deployment unit is pods. It is not same as containers. In Kubernetes, pod are the smallest deployment units and controllers like deployments. If a pod dies, Kubernetes will automatically spin up identical pod replacement instantly. It manages persistent storage volumes that remains intact even when the container dies. So in Docker, where the container dies or it was stopped or it had some issues in its host, etc., the container was useless. We needed to deploy the same container again or manually do it. It's not same in Kubernetes. Kubernetes uses pods that are like the smallest deployment units. So if a pod dies, Kubernetes creates identical of the same pod automatically. Also manages storage of the container if it dies. Second is solution to single host nature. Kubernetes operates on a cluster, a pool of multiple servers. The Kubernetes scheduler continuously monitors the resource usage, CPU or RAM of every server in a cluster. When we launch a new container, the scheduler automatically places it on the server with the most available resources. So simply you can understand cluster as a collection of instances or multiple servers or multiple virtual machines or multiple instances like Ubuntu free tier. So Kubernetes doesn't necessarily operate on a single instance. It operates on multiple instances that are called clusters, which is like a pool of multiple servers. So there's a concept in Kubernetes that is scheduler that continuously monitors the resource usage, that is CPU or RAM of every server in the cluster. So when we launch a new container, the scheduler automatically places it on the server with most available resources. Also, Kubernetes can add more resources, that is increase the cluster size or downscale the cluster size to if the resources are above the need, and if we don't need some resources, it can also scale down the cluster, that is the number of servers, which was missing in the Docker, the platform. Solution to auto healing. Kubernetes uses liveness and readiness probes. It actively checks the health of our application. If a container stops responding or fails a health check, Kubernetes kills it and starts a brand new automatically. So Kubernetes has a concept of auto healing, which is completely missing in the Docker. So it uses liveness and readiness probes. It actively checks the health of the application. If containers stop responding or fails a health check, Kubernetes kills it and starts a brand new automatically. Solution to autoscaling. Kubernetes features the horizontal pod autoscaler HPA, in which we can set the rules. For example, if the CPU usage goes above 70% scale up. So that will allow Kubernetes to automatically launch more containers to handle that load and use its built-in service resource to load balance the traffic across all active containers. We will understand this concept further in our later videos. However, in short, Kubernetes has HPA, horizontal pod autoscaler, in which we can filter out or we can give instructions in a YAML file, which would mean like if CPU usage goes above 70%, that means there is more incoming traffic in the containers. So the Kubernetes would automatically launch more containers to manage that load. In short, it would load balance the traffic across all active containers, so all containers are healthy. So that is it for the video today. In this video, I explained the concept of Kubernetes and its benefits and how it solves the drawbacks and limitations of Docker. Thanks. Have a great day. Bye.